So we're going to cover a little bit about using pointers and references and functions. I'll be using Emacs, so use your cheat sheet if you got one. Okay, so SSH into a computer on the lab. And then cd. I'm going to make a new directory to do some tests in. Okay, and I'm just going to open Emacs. And I'm just going to do t.cpp for testing. Yes. Okay. So just like most C++ programs, include IOStream. Okay, I'm also going to include vector. We'll use that later. And using standard namespace. Okay, so first I'm just going to do a quick little highlight on pointers and references. So let's make an int. Okay, so obviously we know how ints work, but let's make a reference to this int. And so this reference would be similar to the kind of references you would probably experience in Java and C#, except this one is being done on a primitive and not an object. So this is going to just equal, oh no, XR, I have to name it something else. So XR is my reference to X. Okay, and I'm also going to make something else called a pointer. So we'll use the asterisk for pointers. And this will equal, I have to get the reference to X. Okay, so this is kind of like an alias. Anytime you change X, this will change. And this also points to X in memory, but you have to dereference this specifically if you ever want to look at X. So this one is friendly. Where you don't have to dereference it every time, but then you also can't change it. It's locked to X now until death do them part. And this one is more useful, but obviously it requires you to do more things when you need to use it. Now, if you'd think you could put XR here, you can't. So the ampersand is doing something slightly different here than it is here. So here it's specifying a reference, and here it's getting an address. Okay, so let's see what these look like. Okay, so we can see X itself, the value is 10. The reference looks exactly like X, and this is some big long pointer, some address in memory. Okay, but let's say we wanted to get the pointer here to actually tell us the value X, because it's not any good if we can't actually look at what's there in memory. So I'm just going to wipe. Let's see, and okay, so Control W, wipe. Control Y, yank it back. Control Y, yank it back. Okay, and I am going to do a star here to dereference it. Okay, and So similar to how we used star here to say that this is going to be a pointer, we use a star here to say, get me whatever is at the end of this pointer. So subtly different meanings, but you know. So control XS, Z. Okay, so there we go. If we use the star, 8 equals 10, just like the other ones. So with the reference, if I were to say XR equals 4, then suddenly everything will now equal 4 because I have used this reference to set the original value to 4. Okay, and likewise, if I were to create a new value and say XR now equals Y, even though this looks exactly like how I set it in the first place, it's not. It's going to be the same as this XR equals 4. It's going to set everything now to Y's value, 33. So let's see what that looks like. Save it. Okay, so we can see it changes everything when we change XR both times, whether we're setting it from a variable or setting it from a constant. Okay, so let's see what this looks like in functions. I'm just going to return 0. Okay. And so this will just keep all this stuff from printing so that way it's not too messy on my console. So let's make ourselves some functions. So the first function is just going to return nothing, swap by value, and it'll take an int and another int. Okay, and just like any swap function, you know, you're familiar with them. You just set it to a temp value. So let's do int a equals 100, b equals 4, and swap by value. Well, let's first do let's output these. So out. Okay, and swap by value. And wipe yank. And yank a new one here. Okay, and just like Java and C++, or in C#, this will do nothing. Okay, so it didn't swap it, and the reason is, of course, because these are brand new values. So even though these are swapping, they have nothing to do with these values out here. So let's change that using our pointers. I'm just going to use shift and, I missed my lower curly brace. Shift and arrows, and then control W for wipe, and yank it back, and we'll yank back a new one. So now this will be by pointer. Okay, so this will now be a star. So now, instead of just ints, we're taking in pointers to ints. Okay, but just like we did earlier, we're going to have to dereference this. So give me whatever is at the address provided here and save it in temp. Give me whatever is at the address in B. And then if I were to save it to A, that would actually change this address to be equal to the value in B, which is somewhere in memory, but nowhere we need to be. So make sure you also dereference the address you're setting the value to. And same thing down here, dereference B, and set it to temp. Okay, so let's use our new function now. Swap by pointer, PTR. And just like when we created our pointers down here, we need to use the ampersands to get the references, the addresses, to be variable. Ooh. Ooh, typo. TR. Okay, so now they actually swap. But that was kind of messy. You know, we had to put stars everywhere and manually get the references. So let's do something a little bit cleaner. Okay, so, oh, that was Control Y. I still had the function in my clipboard, so I just yanked it back in. This would be by reference. So just like we did with the pointer, except now with references, use the ampersand. Okay, and now, just like we saw with references, I don't have to dereference any of this. And down here, where we're calling the function, I do not have to get these addresses anymore. And they still swap. Very nice. Okay, so let's bring this back. So somewhere where this might come up a lot is with objects. You know, you're used to passing an object in by reference. So let's see what this looks like in C++. So I'm going to make a vector that holds ints, call it v, and then I'm going to add dot pushback value 100 to it, and I am going to return 0 to block all of my other input. Okay, so I'm going to make a function v manipulate. Okay, and this will take a vector. Okay, and I'm going to just change the first value in v to equal 1. Okay, so we have put 100 into our vector. Let's call v manip. Pipe v into that. Maybe it'll change it to 1. Maybe it won't. And now let's call. Let's actually do this. Okay, so cout v 0. Wait, yank, yank. Okay, so now let's see if this changes. Okay, and it did not change. And this is obviously different from Java and C#. So the reason this is because even though we made a vector, which is an object, we did not make a pointer to a vector. So here, where we're passing it into our function, this might as well be a primitive. It's making a new copy, and that's the only one we're messing with. So once we're back out here, just like a primitive, you know, we're using this one rather than this one. So we can use our reference here to force it to pass by reference. So ampersand. Okay. And now it actually changes. So this makes it behave a little bit, this makes it behave a lot like, if you were to just pass an array list in Java or C#, when you actually make changes in the function, they are reflected outside the function as well. And you'll notice, unlike C#, we did not have to type ref here when we called it. So this looks just like if we were passing it in by value. So just be careful, because you might not always know that it's going to be messing with something out here. Passing by reference is fairly common, though. Basically, make sure whenever you make your functions, if changes you make in the function are not showing up in your program, this is probably what's going wrong. You're probably passing it by value instead of by reference. So always keep an eye out for that. Thank you.